Hello, this is the Carmen project. Meet our team of four. Anya Bazida, she worked on the robot side of the project. Pratyusha Ghosh worked on both the robot and the React web app. Kara Hoagland worked on the app side development, and Sinchin Sie also worked on the web app development. Carmen, the cognitively assistive robot for motivation and neurorehabilitation, is a robot designed and developed to teach people with mild cognitive impairment strategies that help mitigate the effects of impairment in everyday life. These include things like calendaring and note-taking, all scaffolded in the robot's delivery through activities and games. These were all designed alongside clinicians who deliver the in-person intervention and are imagining ways that it can be supplemented through engagement at home with a robot. To better understand the need for an expert-in-the-loop interface for Carmen, we will walk you through an example. Imagine a patient attempting an activity with Carmen. Carmen asks the patient to remember previously mentioned instructions. However, the patient cannot remember them. What do we do in such a situation? Now, if there was an expert observing the interaction, they may be able to notice that the patient is struggling or would be doing better with some different prompting in the situation. But how do we adapt Carmen's actions based on the expert's knowledge and observations? To do this, we created an expert-in-the-loop system that consists of an interface and a control mechanism to allow clinicians to interrupt robot-delivered intervention content with novel prompts and animations at any point during the interaction. This system will allow clinicians to personalize intervention content and will enable our long-term goal of creating an expert-in-the-loop system to enable that personalization to run autonomously. We had several key milestones while building the system. First, our MVP consisted of a React app with a single button that when pressed makes the robot say congrats. Next, we worked on allowing more customization for our interruptions, enabling better adaptability to the situation. Next, we improved the security of our application by adding authentication and a login page. Following that, we worked on taking a list of current behaviors from the bot and visualizing them in the app, and added the ability to pre-plan interruptions for further down the list instead of immediately. We then created a history page that displays all the interruptions the user sent to the robot as a reference. Finally, we refined the interface design so as to make it more intuitive to use and visually appealing. Now, we will show you a demo of our final project.
Hi there, my name is Carmen. I can interact and play different games with you. This is an example of a scripted prompt. I will continue with scripted behavior until an interruption is given. The interruptions are processed in a ROS node which handles a WebSocket connection to a React web app. For example, in the web app, we will now send a message that is not in the scripted behavior. This is a custom prompt. They are then sent to a behavior controller which then performs the necessary action. We also send an updated truncated list of behaviors we are running to the web app. That's it for our demo. Thanks for your attention.
Thank you.